So up to this point, we have learned how to graph an equation, one equation at a time, right? Right. We need a title. And this title today is, look at this new marker.
Pretty!
I think they're lies.
No, it's just capital. So you can be all that.
What happened to him?
Ow!
Okay, and this is you. So I can.
Oh. Well then. No.
Okay, so you should all be writing this down in your notebook. So write that systems of equations, simultaneous equations. You're not going to need this. You're not going to need this for tonight's homework, or for the weekend homework, but you're going to need it for next week's homework. So we're getting a sort of head start on this. So up to this point, I've only given you one equation at a time to graph. Now, when they say systems of equations, so why would they say that? What does that mean? Like if you had a stereo system, what's that mean? The stereo system. Who knows? What does it mean? You got it at home. You got a stereo system. What does that involve? What's that include?
Radio.
A whole bunch of stuff. Like what stuff? You need to have speakers. What else do you need to have?
TV?
Well, sure, okay. TV, I guess nowadays, I guess you need something like that. That's part of the stereo system. What else? I mean, you need a tuner, right? You can use a radio of some sort. You probably need a CD player or something like that, right? So it's a lot of things. It's not just one thing. A system is the same idea in math. Like a stereo system involves many things, many components. Okay. Stereo system involves many components. Same with the systems of equations. So I could ask you to, I could give you two equations, and I could ask you to graph them together on the same line. Excuse me, on the same graph. And that would then be a system. You guys, you got to be focused here, not there. Otherwise, you're going to have to go back to everybody's going to go back to their seats. So you've got, if I gave you two equations, let's do it. So let's say I give you y is equal to negative, y is equal to negative 1/2 plus 3. Y is equal to negative 1/2 x plus 3. And then let's say I gave you y is equal to x minus 3. All right, so I give you two equations. So there's two equations. And I said, solve the system. And this is what I'm saying. Solve the system. All right, so the way you do that, there are three different ways to solve systems. And I'm going to write them right now. Three different ways. There's three ways. And we're only going to learn one of them today. The first way is by graphing. The second way is by substitution. And that is actually substitution. And that is actually an algebraic approach. And the third way is elimination, which is also an algebraic approach. We're only going to work on number one today. I'm starting this one early because the book takes forever to teach certain things, and I can't always wait. So we're going to learn graphing today. Next week we're going to talk about substitution and maybe elimination, so that you really get the whole story. Okay. But the main thing is, let's say you look at your homework and it says here's two equations. It says solve the system. The question is, what does that mean? It means I need to graph it. I have to graph each one. So let's try it. I'm going to try just turning this. Hopefully this is going to work. All right. So I don't know. Well, you guys can see it at least. It's not going to be the best on the video, but I'm going to just put my graph here. Okay, so this is my y-axis, and this is my x-axis, right? So I'm going to graph the first one. Y is equal to negative 1/2 x plus 3. Negative 1/2 x plus 3. So what's the first thing I do? Less than 10 seconds. We use that method.
Go over 3.
Go to +3, then go down 1.
Okay, but is that plus 3 on this axis or is it on this axis?
Y-axis.
It's always on the y-axis, right? So I go up to plus 3. So I'm going to go plus 3, and I'm going to put a dot. So this is going to be, I'm doing y. Can you see that? Okay. Y is equal to negative 1/2 x plus 3. And that is going to be, so we at 3. Now we're going to go, our slope, we're going to fall 1 and run 2. So we're going to fall 1, run 2, put a dot. Now this is important. This is where, literally, you only need 2 dots to draw a line, right? But to solve systems of equations by graphing, this is really key, so pay attention. Use the slope several times, put a lot of dots, okay? Because you are going to be looking for something, and that's going to really help. You want this to be as accurate as can be. So I'm going to go down and over 2, down and over 2, down and over 2. In fact, over here I'm going to go up and over 2 this way. I'm going to just keep going for a ways so I can, up and over 2, up and over 2. So I know that is a pretty straight line. So I can now draw that line. I'm trying to be as accurate as I can. I'd use a ruler if I had one. I guess I do, but let's pretend I don't. Okay, so that's my first graph. Right? Now I'm going to use a different color. Orange sounds like fun. All right, so this one now is going to be y is equal to x minus 3. Y is equal to x minus 3. And I'm going to graph that one. So what do I do now? So Wyatt, what do I do? Y is equal to x minus 3. What's the first thing I do?
So go down 3.
Okay, so from here I'm going to go down 3 and I'm going to put a dot, right? And then what? What's my slope? 1 over 1. So what am I going to do?
Go up 1 over 1.
Up 1 over 1, I'm going to put a dot. Now I'm going to do it again. I'm going to keep going. Up 1 over 1, put a dot. Okay, up 1 over 1, put a dot. Up 1 over 1, ooh, look at this, put a dot. Up 1 over 1, put a dot. Up 1 over 1, put a dot. Up 1 over 1, put a dot. Now I'm going to draw my line as straight as I can. Okay. I didn't put my arrows, did I? Okay. We just graphed the 2 equations. We graphed these systems of equations. Now, given our graph, what do you think, pictorially, as you look at it, visually, what is the solution? What?
It's an X. Looks like an X.
It's an X, but what do you think is the solution? There's only one solution to this system.
Oh, is it the intersect point?
Yes, it's where they intersect. That is what you're always looking for. That's the only thing you're looking for, that one dot, that one place. And we were lucky because, look, this one went down 1 and over 2, and it hit that little corner right there. This one went up 1 and over 1, and it hit the same point. So that point is really easy. So we know that point is over 1, 2, 3, 4, up 1. So it's 4, 1. So 4, 1 is that point, 4, comma 1. So my solution, the solution is 4, comma 1. Pretty easy, right? Not hard at all. It's everything you already know how to do. You're just looking for where they meet, right? The problem with graphing is that number one, if you're not very accurate, you won't find that point very accurately, and then it'll be wrong, right? And the other problem with graphing is the point is not always right on where they intersect. They could intersect here. Like, look at this. What if they intersected here like this? What's the problem with where it's intersecting there?
There's no dots.
Yeah, and the dot would be right here. What is that point? I don't know. I mean, it's somewhere in between. It's not on a corner grid, right? It's somewhere in the middle. It's like, I don't know, a third, you know, I don't know. I have no idea. I mean, I have an idea, but it could be, you know, it could be anything. It could be like 17 22s, right? Or it could be, you know what I'm saying? It could be over like -2 and what? I don't know, 2/3, or maybe 2 3/5, or maybe 2 7/9. Who knows what it is? So that's the problem with graphing, is because you've got to, number one, be extremely accurate and extremely careful when you're graphing to find those points. But it really helps if you use the slope many, many times, because oftentimes you'll see that they hit the same point, and that's awesome. They don't always. That makes it more complicated. Now, once we found a solution, by graphing, we have to be sure it's the right solution. So we actually have to check our answer. Now, checking our answer. This is my x, right?
Yeah.
And this is my y?
Yes.
All right, so let's remember that. I'm going to put even x over here and a y here so I can remember. And I'm going to take each equation and I'm going to check it. So I'm going to try the first one, y. Y equals -1/2. Instead of x, I'm going to put 4 times 4 plus 3. And now I'm going to solve that. I'm going to say, okay, so what is 1/2 of 4, first of all? Yeah, 2. So, and it's negative, so it's going to be -2. Y is equal to -2 plus 3. And what would that equal? 1. So y would equal 1. Ah, look, that worked. So that checks. I'm going to put a big check there. And then now I'm going to try this one. Y is equal to x minus 3. And I'm going to now replace that x with a 4. Y is equal to 4 minus 3. Y is equal to 1. Yes, it checks. So this is my answer. The solution is 4, 1. Pretty easy, right? Pretty straightforward. They just get messier. And because they get messier, it gets harder and harder to solve them by graphing. But you'll be working on this a little bit next week. That's as far as I'm going to go with it today. But that is systems of equations, solving it by graphing. As we move forward, I'm going to teach you 2 different ways that allow you to do it algebraically instead of with a graph. And it's much more accurate. Yes?
Is this the only lecture we're having today?
This is it. This is the lecture. Is that clear? Do you want me to do one more, or do you think you have it?
I
You
think we
grab-
are okay.
I'm happy to make the lecture go on another 15 minutes and then have 3 minutes for math soccer, but if you'd rather, we could do math soccer. Okay, math soccer. All right, so that's it on the lecture. It's kind of a weird video because I did everything all over the place, but that's okay.